Hey guys, welcome to the video. So today I talked about ChatGPT and how, as IC designers, we can leverage the software for like quick bare templates of Verilog codes. And Verilog-A, we try to look something up, but it's really detailed. But it's still going to show you what parameters do you need in a complete model. So it's a fun video. We simulated the model we got from it because it also gives you a test bench and it explains what's happening in the code, because I understand block by block what's happening. If it's a big file, I can break it down and digest it. So let's take a look, and it's a fun video. I wanted to see what we can do with this piece of AI, and it seems promising. Free version is okay, so let's take a look. Okay, back to the drawing board. So the first thing we want to do is we want to open up the website. So for this, we go to OpenAI, and we can log into ChatGPT. So we can either use Hotmail or you can also use Google. I use Google, and it's really simple. You just use that account and you're in ChatGPT, okay? So let's click this button and it's gonna take me to the website. Okay, so this is the interface. I'm sure so many of you must have seen this already. And let's say I want a code for an inverter, okay? So it's really simple. What I just do is I say, write a Verilog. Okay. And the more specific you get with your commands, the more accurate results you get. It's just really generic right now. So it's just going to give me some code, you know. So let's say I want to say write code for flop in Verilog-A. Okay, let's see. So it just starts whipping out the code really quick. Okay, it tells me what's the code and it explains you what's happening there. So if you're completely new, you're just trying to learn, you're just trying to get a bare template, you'll have an idea of what you're talking about. Okay, so let's say I want the test bench for this. What I'm going to do is write a Verilog code for Verilog test for, or I can just simply say write a test bench as well. That's fine. It remembers, it has memory. So let's say bench for D synchronous, right? A D flip flop. Okay, let's see what's up. So D flip flop here. Okay, let's see, D flip flop. Okay, that's sweet. So we get the code. Okay, and it's going to tell you what's happening here. It's not just going to write a code and then you're like, what do I do with this? Okay, so now it explains what's happening in each block. I really like this part. Yep. Yeah, so now let's say we have the code and we want to test how is the code working. So you can use Model Sim or any kind of simulator you use. I like to use EDA Playground. It's just online, and I've hooked it up to my school email address, and then I can use commercial simulators to access all those things without logging into my server or using anything on my lab computer. So I just quickly go online from anywhere and I can test the code really quick, see the waves, and done with it. So if I like it, then I go to my server and copy the code. So let's say I have this code earlier. I did this. I don't know why it gives me different outputs every time. So it's also D flip flop. So we got this thing here, and then I asked for, it also gave me asynchronous version here. Okay, and then I asked for a test bench, and we got the test bench here. Okay, and the explanation like earlier. So let's say I want to quickly see if the code is working. So what I'm going to do is copy the code. Okay, and then we go to the website, which is EDA Playground in my case, but you can use any simulator you want. So I come here and I create a new fresh template, and then what I'm going to do, this is for design and this place is for your test bench. Okay, so let's copy the code here, easy and quick, and then we go here. Okay, sweet. We go here, I copy the test. Okay, so I have chosen Cadence, but you can choose any of these simulators here. I like this platform, and then your choice of design language. You can pick up any of these. So right now we are in system Verilog or Verilog. So you click this button to see the waveforms. If it's not clicked, you won't see the waveform. And after this, you also have to put 2 lines of commands, which is really simple. So I'm going to show you what happens when we do it without using those 2 keywords. So it's not going to go through. It's going to give me an error, but let's just walk through it. Okay. So I do this. The names are same. Okay. And no VCD file found. So what we do is we just need to add these things there. So what I do is, okay, after, yeah, let's put it here, okay. And then we also need this. And here, what goes here is, if you're actively simulating, you know these files. So what I'm gonna do is 0 and the name of my test bench, okay. Sweet. Okay, so now if I hit simulate, we might be able to see those waveforms. Okay, so here's the log, tells you everything, what's running. So here it is, the log is here, and we can see all the results here. And if you want to select your results, you can do that too. So what I do is I go here, and then you have the DUT and all these things here. So you choose these signals, but in our case, we are already here because we use the monitor command. So we can see DNQ propagating through and resets it again and again. So what it gives you is a bare template, and then you can tune it according to your specific application. So let's say I want to see what's happening with, if I try to get something bigger, then I really want to make sure I know what's the in and outs of the code. But it's really nice as a starting point to get something. So let's say I just want to shift register. Okay, let's see. Okay, Verilog code. Okay, let's see what we get. Okay, and then you always want to make sure you test it and read through it, understand if it's exactly doing what you want. And I mean, it's a good starting point. Yeah, you're getting it, so that's fine. I like that too. So we get all these things. Okay, and then you can always like earlier, you can also ask for a test bench, and then you can test it, optimize it, and then maybe use it, hook it to your technology file, do the tape outs, whatever you like to do. Yeah, so just gives us like a template. So it's explaining what's happening here. And then I was really curious about what does it do when I ask for Verilog-A models, because Verilog-A models can be really extensive in detail. We use it sometimes. So let's say I want a Verilog-A model for an op-amp, okay. But I was surprised that capability is really powerful. Let's say it has a lot of parameters, but I'm just going to define gain of 10,000, 80 dB. Let's say bandwidth. GWB, I can also write GWB. It has to be realistic. Let's just say 5 kilohertz. Okay. Thinking. So it gives us a model, like a bare model, but it has a lot of things which are missing. So yeah, it's going to tell you what's missing. When I saw that, I was like, okay. And you can also compare it to online models. If you have something really quick, you want to test it, okay, this is what's happening, and maybe these are the things or specs we need to define for any like project you're doing. So it's going to keep on whipping out the code, and then if you like it, you can have it, because it's an op-amp, it's a complex circuit, it has a lot of things going on here. And yeah, these are the things I wanted to try with it. So let's say if you're doing mixed mode simulations and if you want a digital block and you're mostly designing analog stuff, then you can use it as a bare skeleton to get a head start and then optimize and tune it. Okay, it's gonna keep on doing its thing. So that's about ChatGPT used for our digital and analog guys. So we can also use it in our way. And now they're coming up with a new paid version. I've heard about that. It's $49 per month, I think. So I don't know, but this version is also nice. The problem I was facing here is when I try to do two searches, sometimes it gives me different results for two searches. So I think the paid model is going to take care of that thing. And that's nice. That's what I wanted to show you today. And I'll see you next time.